Welcome to True Projects. In this video, we are going to explain about the project, which is DLTIF, which means Deep Learning Driven Cyber Threat Intelligence Modeling and Identification Framework in IoT-enabled maritime transportation systems. Introduction of the project. The increasing affordability and availability of low-cost Internet of Things, which are IoT sensors, have led to significant rise in embedded devices within the maritime world, particularly in maritime transportation systems. This growth encompasses a network of sensors and infrastructure associated with ships, ports, and transportation elements, enhancing overall efficiency. The integration of IoT devices into MTS brings flexibility and intelligence to inter-maritime process. However, this convergence combined with the always online nature of IoT devices exposes MTS networks to serious cybersecurity threats. The vulnerability to both physical and cyber attacks poses a threat to the entire transportation system, making it susceptible to devastating cyber attacks. In the context of IoT-enabled MTS, two primary types of attacks are identified. Physical attacks, which manipulate hardware components directly, and cyber threats, employing malware or gaining unauthorized access to IoT network elements. Traditional cyber defenses, including firewalls and intrusion prevention systems, are shown to have limitations against sophisticated and dynamic cyber threats. The openness of IoT-enabled MTS networks make them highly susceptible to zero-day attacks. To counter this, there is a crucial need for intelligent security solutions capable of automatically detecting and responding to a new and evolving cyber threats. Cyber threat intelligence emerges as a key concept, focusing on evidence-based threat analysis to bridge the gap between attackers and organizational defenses. Existing security solutions relying on statistical and classical machine learning techniques faces challenges such as complexity, lower detection accuracy, and high false alarm rates. The motivation for this project arises from the shortcomings of conventional approaches, leading to the proposal of a deep learning-driven cyber threat intelligence model specifically tailored for IoT-enabled MTS networks. The aim is to overcome the limitations of the traditional methods and provide a more adaptive and effective solution. Objective of the project is to create a comprehensive and automated system named DLTIF, which utilizes deep learning techniques for modeling cyber threat intelligence in the context of IoT-enabled maritime transportation systems. This framework not only understands and characterizes different types of threats but also automates the identification process. The objective is to enhance the overall security approach for IoT-enabled maritime transportation system by incorporating artificial intelligence models. These models will be able to comprehend various cyber attack patterns, thereby enabling the development of more effective strategies to safeguard data within maritime transportation network. The objective is to attain a superior level of accuracy in detecting cyber threats within the IoT-enabled MTS. This involves surpassing the performance of both traditional methods and more recent state-of-the-art approaches. The emphasis is on creating a model that not only automated but also more precise in identifying potential security threats. The project focused on development of a specialized scheme, the Deep Feature Extractor, which is DFE, which employs deep learning techniques, specifically long short-term memory-based variational autoencoder. The purpose is to automatically extract latent threat patterns from the large and unstructured data generated by IoT-enabled MTS network. This objective involves the creation of a CTI attack type identification. This aim is to assist the security analyst in promptly adopting defensive strategies based on the identified threat types, thereby minimizing the potential impact of cyber attacks on the IoT-enabled MTS network. To implement this project, we need software and hardware requirements. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. To implement this project, we have designed various modules in the flow of code. So the first module is importing the packages. In this step, we will import the necessary Python packages and libraries that are required for executing the project. we have imported pandas for data manipulation, NumPy for numerical operation, Matplotlib and Seaborn for visualization, scikit-learn for machine learning, TensorFlow and Keras for deep learning, Flask and SQLite for web development. The next module is exploring the data. This step involves loading the NF, TO and IoT dataset and exploring its structure. We will examine the data to understand its features, data types and potential challenges. This exploration helps in gaining insights into the dataset before further processing. Coming to data processing, here we have three sub-modules. The first one is Pandas data frame. We convert the dataset into Pandas data frame, which is a powerful tool for handling tabular data. Pandas provides functionalities to clean, transform and analyze the dataset efficiently. Coming to Keras data frame, here we convert the dataset into Keras data frame. Keras offers efficient data handling capabilities, especially beneficial when we are working with the large datasets in the context of deep learning. Coming to dropping unwanted columns, we identify and remove unnecessary columns in the dataset using Pandas data frame operations. This step is crucial for optimizing the dataset and improving computational efficiency. The next step is visualization using Seaborn and Matplotlib. Here we utilize Seaborn and Matplotlib libraries for data visualization. Here we create plots and charts to better understand the distribution of the data, identify patterns and gain insights into the relationships between different features. The next module is label encoding using label encoder. We encode categorical variables using label encoder. This step is crucial for machine learning models as they typically require numerical input. Label encoding converts categorical data into numerical format. The next module is feature selection. We use select percentile with mutual information for feature selection. This statistical method helps in identifying the most informative features, improving model performance and reduce overfitting. Coming to the seventh module, which is appending selected features to X and target column to Y. Here we organize the dataset into features as X and the target variable as Y. X contains the selected features while Y holds the target variable that model aims to predict. Splitting the data into train and test. Here we split the data into training set and a testing set. The training set is used to train the machine learning model while the testing set is reserved for evaluating its performance. Building the model. Here we create machine learning models for binary classification and multi-class classification. We build multiple deep learning and machine learning models for detecting the cyber threat into IoT-enabled maritime transportation systems. Binary classification has 2 class labels. Multi-class classification has 2 and more class labels. The next step is training the model. Here we train the machine learning models using the training data. This step involves optimizing the model parameters to achieve the best possible performance. As an extension, we applied an ensemble method, which is stacking classifier and hybrid model that combines the prediction of multiple individual models to produce a more robust and accurate final prediction. As an extension, we built the front end using Flask framework for user testing with user authentication. Coming to the next module, which is Flask framework with SQLite for sign up and sign in. Here we set up a web application using Flask framework, implemented a user authentication system using SQLite for sign up and sign in functionalities. User give input as feature values. Users are allowed to input feature values through the front end of the web application. Coming to the next module, which is the given input is pre-processed for prediction. Here we pre-process the user input that to align with the format expected by the trained machine learning model. This includes encoding categorical variables, scaling numerical features, and handling missing values. Trained model is used for prediction. Pre-processed user input is utilized to make predictions using the trained machine learning model. The model will give output predictions based on the provided features. Coming to the last module, which is final outcome, is displayed through frontend. Final prediction outcome is displayed on the web application frontend to the user. Algorithms which are used in this project are long short-term memory, which is LSTM with variational autoencoder. Long short-term memory is a type of recurrent neural network architecture designed to address the vanishing gradient problem in traditional RNNs. LSTMs are capable of learning and capturing long-term dependencies in sequential data, making them suitable for tasks involving time series or sequential patterns. Coming to variational autoencoder, It is a type of generative model that learns a probabilistic mapping between input data and a latent space. It is often used for dimensionality reduction, generating new data points and representing complex data distribution in unsupervised manner. In this combination, LSTM and VAE are likely used together in an integrated manner. LSTMs capture sequential dependencies in the data, crucial for understanding temporal aspects, while VAEs provide a generative framework for learning and representing the underlying distribution of the data in a probabilistic manner. LSTMs capture time series patterns and dependencies essential for intrusion detection in scenarios where the order of event matters. VAEs can model the latent space of the normal behavior, allowing for the identification of anomalies and deviations from the learned distribution. The next algorithm is bidirectional gated recurrent unit, which is BIGRU. It is a variant of gated recurrent unit, which is a type of recurrent neural network. The bidirectional aspect allows the model to consider information from both past and future time steps when making predictions. BIGRU is chosen for its ability to capture dependencies in both forward and backward directions, enhancing the model's understanding of sequential patterns in the data. This is advantageous for tasks like intrusion detection where comprehensive context is crucial. The next algorithm is decision tree. It is a tree-like model where each node represents a decision based on the value of a particular feature. It recursively splits the data into subsets, making decisions at each node until a stopping criterion is met. Decision trees are used for their simplicity and interpretability. They can handle both categorical and numerical data, making them suitable for datasets with a mix of data types. Decision trees are often employed in intrusion detection for their ability to reveal decision paths that lead to potential security threats. Coming to random forest, it is an ensemble learning method that constructs multiple decision trees during training, and the output, the mode of classes, which is classification, or the mean prediction, which is regression of the individual trees. Random forest is utilized for its ability to improve predictive accuracy and control overfitting. By combining the predictions of multiple decision trees, it provides a robust and generalizable model. In intrusion detection, random forest can capture complex relationships in the data and enhance the overall performance. Naive Bayes. It is a probabilistic classification algorithm based on Bayes' theorem with the assumption of independence between features. Despite of its naive assumption, it often performs well, especially in the text classification and spam filtering. Naive Bayes is chosen for its simplicity, efficiency, and ability to handle high-dimensional data. It is particularly effective for text-based data, and it is employed in intrusion detection for its speed and suitability for datasets with many features. The last algorithm, which is DFE, which means Distributed Feature Extraction based IDS, which is Intrusion Detection System, and ANN, which is Artificial Neural Network. Coming to DFE, which is Distributed Feature Extraction, it is an approach to extract relevant features from the data that is distributed across multiple resources or components. It involves collecting and aggregating features from different parts of a system or network. Coming to Artificial Neural Network, it is a computational model inspired by the structure and functioning of the human brain. It consists of interconnected nodes organized into layers, including an input layer, hidden layer, and output layer. ANNs are capable of learning complex relationships in data through training on labeled examples. This combination involves using a distributed feature extraction approach within an intrusion detection system coupled with use of an artificial neural network. DFE extracts relevant features from distributed sources, and ANN model the complex relationships in these features for effective intrusion detection. DFE efficiently handles data distributed across the network relevant for scenarios like IoT-enabled maritime transportation systems, where data may be spread across various components. ANN with the ability to learn complex patterns process the extracted features to model relationships indicative of normal and anomalous behavior. To evaluate this project, we have used different classification metrics which are accuracy, precision, recall, and F1 score. So here we have for those metrics comparison graph of binary classification. This is the accuracy comparison graph where on x-axis we have accuracy score for each algorithm and on y-axis we have algorithm names. Accuracy measures the overall correctness of the model by calculating the ratio of correctly predicted instances to the total instances. This is the precision score. Here on x-axis we have precision score for each algorithm and on y-axis we have algorithm names. Precision is the ratio of correctly predicted positive observations to the total predicted positives. It focuses on the accuracy of positive predictions. This is the recall score comparison graph, where on x-axis we have recall score for each algorithm and on y-axis we have algorithm names. Recall measures the ability of the model to capture all positive instances. It is the ratio of correctly predicted positive observations to the total actual positives. It is also called as sensitivity. This is F1 score comparison graph, where on x-axis we have F1 score for each algorithm and on y-axis we have algorithm names. The F1 score is the harmonic mean of precision and recall. It provides a balance between precision and recall. Here we have comparison graphs of multi-class classification. These metrics provide a comprehensive evaluation of the model's performance in the both binary and multi-class classification scenarios, considering aspects of accuracy, precision, recall, and F1 score. The model which performs best among all the metrics is used for prediction. To execute the project, first we need to open the code folder which contains source code files. So this is the code folder of the project, and this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. These are the IPYNB files. These files are the Jupyter Notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. This is the model file, which contains the algorithm information. This will be loaded into the project code during runtime. And this is the sign-up file. This file is the database file used to store the user information. To execute the project, we need to copy the path of the code folder from the address bar of the File Explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This will change current directory to the code folder's path. Here we need to type the command python space app.py and click on enter. This will compile app.py file, and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is the localhost and the port. This is localhost and this is the port, unless configured differently. Now we have to copy this local link provided by the framework and paste it in any web browser. I prefer Google Chrome, so I'll paste it in that. So here we need to paste the link and then click on enter. This is the web page of the project which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a register link. First we need to click on it and enter all the registration details if we are signing up new. I have already signed up and I have an account in it, so we'll directly click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password, and now we need to click on sign in. We have signed in successfully. So here we can see parameters which are need to be entered. So based on the given input, we will get the prediction whether attack is detected or not. Now we will understand all these parameters. Coming to L4 SRC port, which is layer 4 source port. This parameter represents the source port number at the transport layer, which is layer 4 of the OSI model. Port helps in identifying specific process or service on the device. Here we have L4 DST port, which is layer 4 destination port. This parameter represents the destination port number at the transport layer 4 of the OSI model. It indicates the port to which the data is directed. Here we have protocol. Protocol is a parameter that indicates the communication protocol used for network traffic, such as TCP, which means Transmission Control Protocol, UDP, which is User Datagram Protocol, or ICMP, which is Internet Control Message Protocol. Here we have L7 Proto, which is layer 7 proto. This refers to application layer of the OSI model L7 Proto. It indicates a specific application level protocol being used, providing insights into the type of the application generating network traffic. Here we have in bytes, which are inbound bytes. It represents the number of bytes received by a network device. It measures the volume of data entering the system. Here we have out bytes, which is outbound bytes. It represents the number of bytes transmitted by a network device. It measures the volume of data leaving the system. Here we have in packets, which are inbound packets. It is the count of incoming packets. It measures the number of discrete units of data received by network device. Here we have out PCTS, which is outbound packets. It is the count of outgoing packets. It measures the number of discrete units of the data transmitted by the network device. Here we have TCP flags, which represent the flags used in TCP, which is Transmission Control Protocol, which is the header. TCP flags provide information about the status of the TCP connection, such as SYN, ACK or FIN flags. Here we have flow duration milliseconds. It indicates the duration of the network flow in milliseconds. A network flow is a sequence of packets sharing common attributes, typically between a source and the destination. Now we will enter all these parameters. So the L4 source port is 47394, L4 destination port is 80, protocol is 6, L7 Proto is 7, in bytes is 495, out bytes is 3760, in packets is 5, out packets is 6, TCP flags is 27, and flow duration milliseconds is 205. Now we will click on predict. So based on the given input, it is predicted that there is an attack detected and the attack type is either injection, DDoS, password, access, scanning, DOS, backdoor, MIT and ransomware. Now we will give other parameters and see what will be predicted. So L4 source is 57965, L4 destination port is 7678, protocol is 6, L7 Proto is 7, in bytes is 406, out bytes is 1945, in packets is 5, out packets is 6, TCP flags is 27, and flow duration seconds is 10. Now we will click on predict. So based on the given input, it is predicted that there is no attack detected and it is normal. In this way, if we give the parameters to the system will predict whether the attack is detected or not. Now we will log out. Conclusion of the project. The project strategically combines algorithms like LSTM, VAE and DFE-ANN for robust intrusion detection, leveraging LSTM for temporal dependencies and DFE-ANN for efficient feature extraction in IoT enabling maritime transportation system. Comprehensive metrics including accuracy, precision, recall and FN score provide a thorough assessment of model performance, ensuring a balanced understanding of binary and multi-class classification scenarios. Tailored for maritime transportation system, the project addresses the unique challenge posed by dynamic and distributed nature of threats, enhancing security in both physical and cyber domains. The LSTM-VAE combination captures evolving patterns in sequential data, while DFE-ANN accommodates distributed information, ensuring the system's adaptability to dynamic and evolving threats. Beyond model efficacy, the project prioritizes user interaction, employing a Flask framework with SQLite for sign-up and sign-in. This user-friendly interface enhances accessibility, making the intrusion detection system practical and user-driven.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.